All right, notes on distance versus displacement. All right, scalar has magnitude but no direction. So magnitude. So if you say 12 inches, 3 pounds, 45 meters, 5 years, vectors have magnitude and direction. So 12 inches up, 45 meters to the right, 300 miles north-northwest. So if you move something 12 inches up on a shelf, or you lower it, or you move it to the right or the left, putting the direction and the units makes it a vector. All right, displacement is distance from a reference point. Usually whenever we talk about these things, the reference point is going to be the starting point. It will include a direction. So let's say we move to the right 5 steps. So if we draw it in here, we can go to the right, and we'd put 5 steps on there. Then we go 2 steps to the left. So what happens is we turn around this way and go 2 steps. Now, for distance, every step counts. So distance is 7 steps. No direction. Displacement is if I went 5 steps to the right plus 2 steps to the left, since my arrows are an opposite, my displacement is 3 steps. Now what is my direction? It's all based on the reference point. Where are you? Where's the x based on that? It's 3 steps to the right. So we are 3 steps to the right. So sometimes that's hard on these. So if you go one way and then turn around and go the other, it's just a straight add and subtract. What happens if you do things at angles? Well, we'll show you that in just a sec. All right, displacements can have positive and negative values based on our graphing. Okay, positive is to the right-hand side and up, negatives to the left-hand side and down. I don't like positives and negatives because if people mistakenly put a positive and a negative with the left or right, you can actually get the wrong answer based on what you put. The triangle means change in. You know this from chemistry. So triangle x means change in x. So if you're along this line and we move from one point to another point, there's been a change in the x. If we went up into the air, then that would be a change in the y. A change in the y. All right, so let's do a problem here. I think this is what's on your paper. A woman runs east for 1,700 meters for 400 seconds and then turns and runs north 700 meters for 200 seconds. Calculate her displacement and velocity. We're going to talk about velocity in just a sec. So let's just do her displacement and her distance. So I'm going to do distance on the left. And because of this, I'm not going to worry about the time. All right, so what I do is I look at my information. I have going east for 1,700 meters. So I'm going to draw a picture over here. She goes east for 1,700 meters. And then she goes north for 700. Okay. Now, for distance, every step counts. So your distance is simply 1,700 plus 700. And that gives you 2,400 meters. So that's the answer. Displacement is different. What happens with displacement is you're not going to cover all the ground. It's what's the nearest, closest path, and that would be a hypotenuse of part of this. We're going to find the hypotenuse c using the c squared equals a squared plus b squared of the Pythagorean theorem. So what we're going to put in our calculators, we're going to say c equals the square root of a squared plus b squared. So c equals the square root of 1,700 squared plus 700 squared. So the answer to that is 1,838.47. Now, this is such a large number, we really don't care about the decimals. We'll just go 1,838 meters. Now, we need to know this direction is north and east. So we have our number, our unit, and then our direction. Displacement has to have a direction. Okay, now velocity is based on displacement, so it includes a direction. So speed is just the distance divided by time, and velocity is the displacement versus time. Velocity is a vector quantity because it's based on displacement, and speed is a scalar. Remember, the first notes we took on this was vectors require a direction, scalar is just a magnitude. All right, so label this as scalar, vector, or neither, so pause the video, do that on your own, and then check your answers. So pause the video now. Okay, hopefully you're back and you can go scalar, vector, scalar, neither, because there's no unit over here. Scalar, scalar, vector, scalar. All right, a man travels 34 meters to the right in 6.7 seconds, turns around, travels 87 meters to the left in 9.5. So diagram, picture to the right, 34. And then back the other way, 87. Okay, distance, every step counts. 34 plus 87, 121. Time, 6.7 plus 9.5 gives you 16.2 seconds. Speed is distance over time, so it's 121 over 16.2. So speed equals 7.47 meters per second. All right, now displacement. Displacement is different. What we want to do is set up displacement, put the big number, 87, first, and put its direction above it. And then we're going to add the 34, and we're going to put its direction. Now, because the arrows are going opposite directions, we're going to subtract them. So it's going to be 53. The guy going left is bigger, so he's going to win. And then the unit is meters. So the arrow tells us the direction. The time is going to stay the same at 16.2 seconds. Velocity is the displacement over time. So that is 53 to the left over 16.2. And that answer is going to be V equals 3.27 meters per second left. Direction, number, unit, direction, we've got a velocity. Okay, so on the back there's a problem. I'd like you to do it as much as you can and then check your answers here. Okay, delivery van leaves the warehouse, travels north. So we draw a picture north, 189 miles. Then they head east, 157 miles. So the distance is 157 plus 189. You have a lot of room, so I'll do all the distance stuff, and then you can write it down. Then you have some room over on the down below to do your stuff. Your picture doesn't look exactly like this. So that number is 643. So that's 346 miles. The time is 4.5 hours plus 3 hours. So that's 7.5 hours. So speed is distance over time. And 346 divided by 7.5 is 46.13. Meters per second. Excuse me. Meters per hour. So those are M's. I hope your worksheet just has an M and not an MI. All right, so that's how you get it. Straightforward way, no big deal. Now, displacement's a little different. We go back to our picture over here and we say, you know what, here's where we started down here where the red dot is. We want to go to the X. We're going to do Pythagorean theorem. Okay, so the displacements can be found by doing C equals the square root of 189 squared plus 157 squared. So put that in your calculator. Okay, your answer for that is 245.7. 245 is big enough. We don't need to worry about decimals. Just round up to the 246. That's going to be meters, and we're going northeast. You got to have that unit in there. Time is still the 7.5 hours. So our velocity is the change in the displacement over the change in time. So it's 246 or 7.5. Which gives us 32.8. Meters per hour, and that is northeast. Okay? So if you're going back and forth on each other, if you're going left and right or north and south, you can just use arrows like this picture on the front. But if you're going to go at an angle, you have to use things like northeast or right and then left, something like that. We usually use north, south, east, and west because it's easier to get our distances. That's how you do distance and displacement and decide if it's speed or velocity. Thanks for listening.